at 3.6 we completed. We'll look at question 3.7. Question 3.7 says, calculate the magnitude of the force exerted by the floor on the ball for the time of contact. Calculate the magnitude of the force exerted by the floor. The force exerted by the floor. Alright, so what do we know? We know that when it comes to force and what we just worked out in the question before, we know that F net delta T is equals to delta P. And if you look at our case here, we will say MVF minus MVI divided by delta T. And if you take it further, if you have to just go on and we'll say, okay, let's just work out our mass and velocities, etc. Looking at the graph, we can say your mass is 0,05 and your final velocity will be, looking at the graph, it will be the velocity at which it leaves the floor, which will be minus 3,43. Minus 3,43 is when it will leave the floor. And at what velocity does it hit the floor? 3,92. So it hits the floor at 3,92. It's 0,02 seconds in contact with the floor, and it leaves the floor at minus 3,43. So those are the points that we'll have to put in. So if you put it here, it will be minus 3,43 minus the mass 0,05 multiplied by, what was it, 3,92. 3,92 there on the top will be 3,92, and then you'll have to divide it by the change in time at which it is in contact with the floor. And if you work that out, it will be 0,02. And if you work this out, let's take our calculator and work it out. Let's see what we get. We get, let's just cancel, 0,05 times 3,43. That will give you minus 0,1715 minus, and if you work that other piece out, 0,05 multiplied by 3,92, we get 0,196, and all that must be divided by 0,02. And if you work that out, what do we get? Zero comma 1715, and it must be a minus sign. Let's just put this in order. Minus 0,1715 minus 0,196 equals divided by 0,02, and that will give us an answer of minus 18,0 375. So that gives you 18 comma minus 18,36 minus 18,36 newtons. So that will be the net force that occurs in this case. But that's not the question. The question says, what is the force of the floor? So what we'll have to do then is work out force on the floor. We'll have to say net force is equals to the force of the gravitational force plus the force of the floor, which we want to work out. The force on the floor. Alright. So if we just the force on the floor. So our net force is minus 18,36, which is minus 18,36 is equals to the force of gravity, which was 0,05 times 9,8, which was 0,49 plus the force on the floor. And if you work this out, we can say 0,49 minus 18,36. So we get, just to work it out, 0,49 minus 18,36. If we take it on the other side, basically we have to take this on that side, it's minus. So it's work it out. It will be minus 18,36 minus 0,49, and then that will give us the force of the object on the floor. If you work that out, we'll say minus 18,36 minus 0,49 will give you 18,85 minus 18,85 newtons, and then that will be the force of the floor. And then the question we'll be looking at is, it didn't ask the direction, it asks you calculate the magnitude of the force exerted by the floor on the ball for the time of contact. So then it will be 18,85 upwards. Alright, the force on the floor will be the force on the floor of the floor on the ball will be 18,85 newtons. So that will be the answer for question 3.7. Then if you look at question 3.8, the question is, if a softer ball is used and the time of contact with the floor is increased while the change in momentum remains constant, how will it influence the force on the ball? Will it increase, decrease, or remain the same? And it says that you should explain your answer. So looking at this, we can look at the question in terms of the force. We can say that the force will be affected in such a way that the force will decrease. So we should write that down, that the force will decrease. And then to explain it, we should try and see if we can relate it to the equation that we are using. And so let's just write this down, decrease. Let's just write this down, decrease 3.7. We've got our answer, 3.8. The answer is decrease. And then if we relate this to a question that we have, the equation, we must explain. When they ask you to explain, you must always use an equation to explain it. We can say that the equation that we are using in all these cases was F net delta T is equals to delta P. And we can say further that looking at this question, we can say therefore our net force is inversely proportional to time. So thus we can say if there's a softer ball, we can say that force is inversely proportional to time. A softer ball will increase the time. So thus, if the time increases, the force will decrease. So you can say the net force is thus that if any increase in time will decrease the force, we can say something to that effect. A softer ball will increase the time, thus the force decreases. Okay, so looking at that, we've got the answer for point 3.7, we've got the answer for 3.8, and with that we will conclude question 3 relating to our section.